Yes, sir.
In the last class, we saw some basic functions like greatest integer function and least integer function, and we saw the graphs. How do the graphs of these functions behave? The greatest integer function, it is also called as step function, how the graphs behave, and the graph of least integer function. The least integer function
Sir?
also. Yes, tell me.
So last class I was not there. May I know which lesson is going on?
Relations and functions.
Okay, sir.
Relations and functions chapter is going on. And a least integer function we saw. Least integer function, the graph is also again like step only, but step function, that word is reserved for greatest integer function. Okay. So now these were up to, I think so, 8 functions we have seen. So today, moving ahead, 9th one is the fractional part of x. Fractional part.
Sir, could you do a case study, like some case study questions on relations and functions, sir?
Case study questions means what? I did not get you.
Case study questions, sir. How we have case studies questions on science and like other subjects. Excuse me, sir.
Yes, tell me. And I'm not getting case study questions means what are these case studies questions?
So
Actually,
actually it is a new way of question in our question paper, sir.
Yes, sir.
The new pattern, sir.
Okay,
We
a
have
new
case
pattern.
study. It is a yes, sir. In that case study is included, in which there will be given a passage.
Yes, sir, like
According to that passage, or with the lines given in the passage, there will be asked some questions based on the. If
Okay,
there
okay,
is
okay.
like a relation and functions are not the same, but function is the same as the relation, like that, if it is there, then they will ask the questions related to functions or relations, like that only it will be, sir.
like so for any questions we have case studies, sir. Like not only for math, we have for science. They will give a passage and some questions depend on the passage, but we don't have the exact same answer. Like they will like as we get in English, sir, that passage reading thing, we will get the answers from the passage only in English. But in math and science, we don't get the same answer from the passage. We have to read the content and we have to think and write from the like from the given questions. So this time in
Okay.
our test and like this year we are having this pattern, sir, case study question.
Oh, okay, so right now I'm not aware of this pattern. I will check it out and I'll give you those questions in the next class. Will that do?
Yes, sir. Okay.
Oh. Fractional part function. So now fractional part function is what it is denoted by f of x, and this is again a real valued function, f of x from R to R, and it is given by f of x. The symbol is this in curly braces. And what is the definition? Instead of giving the definition, I'll give you the meaning of this. Let's see, means x. You know x, if x any value is given to you, you know the meaning of step x, this in the round bracket, the square bracket x. So x is equals to, when you take step x, some small part you have gone behind, whatever that small part you have gone behind, that is called as the fractional part. So this is the definition, this is the relation between the any value x, its step function, the greatest integer function, and the fractional part function. So this is the GIF, greatest integer function, that we have already seen in the previous classes, and this in the curly brackets is called as the fractional part of x function. Okay, so this is the definition of fractional part of x. So if I give you an example illustrations, if I tell you find the value of fractional part of 15.3, So how you will calculate? Sir, my x is equals to 15.3, correct? What is my step x? Sir, my step x will be equals to 15, no doubt in this. So what will be my fractional part of x? I know that my x is equals to step x plus fractional part. So 15.3 is equals to 15 plus whatever is there. And this fractional part is equals to 0.3. On the number line, if I give you a representation on the number line, pictorial representation will be something like this: 14, 15, 16. This is my x. Here somewhere is my x. X may be an integer, it may not be an integer. Wherever it may lie, x is there. This is my step x. Step x will always lie to the left side. Step x will always lie to the left side of my x because it is the integer less than or equal to x. Less than, so it will always lie to the left. And this difference which is there, will be equal to my fractional part. Okay, so if this is clear to you, then for positives, no doubt, I don't think for positives anybody will face any problem. Like 99.1, what will be the fractional part of x?
Sir, it will be 99.
Fractional part. What is this symbol?
So 99.1.
99.1, and this, when I'm writing it in curly braces, what is the meaning? What I'm asking you actually the fractional part of 99.1. So can I say the fractional part of 99.1 is 0.1?
Yes, sir.
So 99.1, if I give you this way, this symbol means greatest integer function, and greatest integer function is 99.
Yes, sir.
Okay. Symbols meaning you are understanding, sir, how 99 fractional part is coming out to be 0.1. Is there any need to do such big stepwise calculations? Can I skip that part?
Yes, sir.
Okay.
Yes, sir.
So 99.1 step function fractional part is 0.1. Similarly, I don't think anyone will have any problem in this question also. Let's say maybe 151.7 fractional part is equal to 0.7, and let's say 199 fractional part. What will be the answer? Fractional part of 199.
1.
No. 0. So for 199, if x is equals to 199, so what is my step x? So my step x is again 199 only. It is not 198. What is my greatest integer function? Greatest integer function is greatest integer less than or equal to x. No? Greatest
Yes, sir.
integer function definition. Least integer function is also least integer function greater than or equal to x. And greatest integer function also is the same thing, but greatest integer less than or equal to x. Equality is allowed. So here step x will be 199 only. So fractional part, can I say fractional part will be 0? Okay. So now positives, nobody will have any doubts. Negatives, there is a high probability that you will commit silly mistake. Tell me what will be minus 5.2, its fractional part. Give your answers in the chat box. No. Makarand wrong. Pujita wrong. Harini,
Yes, sir.
what's the answer? What do you think?
So as it is negative, I think so.
Pujita, now the answer is correct. Harini, wrong answer. Okay, chalo, see here everyone. Minus 5 if you want to find out. Now what if you go by the traditional approach, means this algebraic approach actually is a long one. You should be able to picturize the value, but okay, let's go first simply by the algebra. X is equals to minus of 5.2. Can you see that step x will be equals to how much? Negative value step function we have seen in the previous class. Negative value step function. If x is equals to minus 2.6, minus 2.6 step function is negative 3. Previous classes we have seen example. Minus 5.4 step value is negative 6. If x is lying over here, let's say this range is minus 3 point something and minus 3 point, then the step function, the greatest integer less than, so greatest integer will be negative 4. So according to that, step function of minus 5.2 will be minus 6. I think here no one should have any doubt. So now what remains is x is equals to step x plus fractional part. X is equals to minus 5.2 is equals to step x is negative 6 plus fractional part. So fractional part of x will be equals to 6 minus 5.2, which will be equal to 0.8. Okay, this will be the answer. But algebraic, if you see it on the number line, the picturization will help you to do these calculations very much faster. Minus 5.2. Okay, so this is my, let's say, minus 4. Here is minus 5. Here is minus 6. And here is minus 7. Minus 5.2 somewhere over here. This is my minus 5.2. Let's say call this as x, and this is my minus 5.2, and my step x will always be to the left. So since my step x is always to the left hand side, which is equals to minus 6, can you see that my fractional part will always be positive? Because what is x is equals to step x plus fractional part. Fractional part is what? Sir, x minus step x. So x minus step x means you are subtracting a lesser number from x. If you're subtracting a lesser number, the fractional part will always be positive, or maybe 0 if, in case x is an integer. Okay, and this distance, this difference is my fractional part. This difference is my fractional part, which is equals to 0.8. What that my 0.2 is leading to you is, so that 0.2 is little bit misleading. That 0.2 is little bit misleading because this distance minus 5.2, it actually this distance is equals to 0.2. After minus 5, you have to go more 0.2 distance towards the left. But I'm not interested in that part. I'm interested in this answer. Okay. Let's change the color. This is my required answer, which is equals to 0.8. Everybody getting it? How to picturize these values? Minus 5.2 means 2 units, 0.2 units to the left of -5. But that is not my answer. I am interested in this. The greatest integer function. How much should I come right side? So to the right side, I have to travel a distance of 0.8. Understood? So the answer is fractional part of minus 5.2 will be equals to 0.8. Fractional part of minus 11.9 is equals to, quickly everyone, yes, Makran, very good. Yeah, Pujita, correct. Yes, Makran, regarding the recording of the last class, I spoke to ma'am. She said that she's also not having the recording. Maybe it was not, means the recording got deleted or something. Try, some problem occurred in the last week. So minus 11 minus 12 here, and minus 11.9. Minus 11.9 will be over here. This is my x. This distance is 0.9, but I'm not interested in that part. My step x is over here. This is my step x, and from step x, how much should I move ahead? How much should I move ahead? So I have to move ahead 0.1 distance. So my answer will be 0.1. Everybody understood this? So now, two questions. Minus 25 fractional part is equals to, and let's say last question. Yes, Pujita, correct. Makran, correct. No, second one is wrong, Pujita. Read the question correctly. Second one is wrong. Yes, Makran, correct. Any understanding?
Yes, sir.
Minus 25, I think so. This should be clear that the fractional part will be 0, because minus 25, x is also negative 25, and the step x, greatest integer function, is also negative 25. So you no need to move anywhere. The fractional part will be 0. Now minus 25.25. Minus 25.25. Why this is complicated, I don't know. Pujita, what answers are you giving? Minus 24, here is negative 25, here is negative 26. minus 25.25. So here is somewhere my negative 25.25. What does this mean? So this means that this distance is 0.25. So what is the remaining distance? So the remaining distance is total distance between two integers is 1. Between two consecutive integers, total distance is 1. So the remaining distance will be 0.75. That's it. Because this negative 26 is my step x. Okay. So step x plus 0.75. To the right side I have to go 0.75. This will be the answer. Clear, everyone?
Yes, sir.
Okay. So now if I tell you to draw the graph of this thing, for that matter, 9, 10, 11, 12. Can you see that 0.1 step function is equals to 0.1 only? 0.2 its fractional part is equals to 0.3 only. 0.3 its fractional part is equals to 0.3 only, because the step function, the greatest integer function is 0, and ahead of that no problem. Now if I tell you 1.1, 1.1 its fractional part, is it again 0.1? Do everybody agree with me? 1.2 its fractional part, is it again 0.2? 1.3 its fractional part, is it again 0.3? Now similarly 2.1 its fractional part, is it again 0.1? And the same story continues. So now if I tell you to draw the graph of this thing, graph of fractional part of x, f of x is equals to fractional part of x. If we just see between 0 and 1, between 0 and 1, if I here is my x, so what will be my, just concentrate on this part between 0 and 1. So between 0 and 1, what is my image? My image y is as actually equal to x only, because if x is equals to 0.1, the image is 0.1 itself. X equal to 0.2, the image is 0.2, so on. Do you get this? So graph will be something like this. Y is equals to x, a straight line passing through the origin. At x equal to 0, when x is tending towards 0, the graph is 0 only. At x equal to 0, the image is also 0. So the left part, you can make it meet at 0. But x is approaching 1. The x is approaching 1, just left of 1 at x, just to the left side of 1, it is, the graph will be y equal to x. But at exactly x equal to 1, at exactly x equal to 1, the fractional part will become 0. Do everybody agree with me?
Yes, sir.
Okay, so at exactly x equal to 1, the graph will be 0. So you convey this message in this format. Then again after x greater than 1, between 1 and 2, again the story will repeat itself. When x is now the same graph as it was between 0 and 1, the same graph will repeat itself as we saw here. So between 1 and 2, as x takes the value between 1 and 2, 1.1, the image is 0.1, 1.2, the image is 0.2, 1.3, the image is 0.3, and so on. The graph will again go on repeating up till it is just towards the left of 2, and at x equal to 2, the graph will abruptly jump down to 0 at exactly x equal to 2. Then again the same story, then again the same story, then again the same story. Okay. Before that also the same thing will happen at x equal to -1, -2, -3. Convey yourself this point that x equal to -1, it is 0, and to the right of -1, when x is to the right of -1, the graph is going upwards. Some students have the feeling that, sir, see here you're taking in the northeast direction, so on the negative side I will draw like this. It is not that case. To the right of -1, the graph is not starting from this point. Okay, convey yourself that this is the right answer. To the right of -2, as x goes to the right of -2, the value, the fractional part goes on increasing, because at x is the graph of fractional part of x clear. So from the graph, can you see that fractional part of x domain of fractional part of x is the complete set of real numbers. Everywhere it is defined. But if I tell you the range of fractional part of x, so the range of fractional part of is everything between 0 and 1. All the numbers between 0 and 1. So 0 will be included, but no, sir, 1 is not allowed. Fractional part will never be 1. Do you agree with me?
Yes, sir.
Okay. And now some properties related to fractional part. GIF is the greatest integer function. Properties related to greatest integer function and fractional part of x function. First, if I tell you x and step x, the step x is defined in such a way that step x is always less than or equal to x. If x is an integer, equality will take place, and if x is not an integer, step x will always lie to the left of x. To the left of x means it will be less than. That is the definition part only. And step x is also strictly greater than x minus 1, because what is step x? It is the greatest. You want an integer to the left of x, but nearest to it. So convey yourself this point on the basis of number line. These three dark circles are my integers. Okay. Now x, the value of x, it may be an integer, it may not be an integer. For example, if x is not an integer, you take x will lie between the dark circles. So if x is somewhere over here, this will be my step x. X minus 1 will be 1 unit behind. If you are going 1 unit behind, there has to be an integer in between. So that will be my step x. Can you see this part? So step x will definitely be greater than x minus 1. And so what about if x itself is an integer? If x itself is an integer here, then x minus 1 will be over here. So that is x, step x is here only. This is only my step x, and which is greater than x minus 1. Is the first remark clear to everyone? First property that we saw?
Yes, sir.
Okay. Second is, you see x and step x plus 1. This is strictly less than. X is strictly less than step x plus 1. Again, see the same diagram. If x is not an integer, somewhere over here, the same diagram that is visible on the screen. So step x plus 1 will be the next integer. This will be my step x plus 1. Equality will definitely not take place between x and step x plus 1. So what about if x is an integer? Okay, if x is an integer, then x and step x are one and the same thing. If x is an integer, x and step x are one and the same thing, and step x plus 1 is the next integer. There also the inequality is not taking place. The equality is not taking place. Okay, so these two inequalities combined you can write as one also, or you can think of them as separate also. Now the third property, x plus n, its step function is equals to step x plus n if n is an integer. If n is an integer. Now this property proof I will give you a visual proof, means from the on the basis of number line, not on the basis of algebraic proof. This is a simple logical proof. See, means from inside a step function you can take the integer outside, like step of x plus n. Forget about whether x is positive, whether x is negative, whether it is an integer or whether it is not an integer. This is my number line. These are some of the integers, consecutive integers. Okay, x may be anywhere. Suppose this is my x. Okay, now what my LHS is, what my LHS is, sir, x addition n. Consider for example n is equals to 3. So when I tell you x plus 3, you have to find out x plus 3. So means you are on the in the school 7th or 8th standard, when we first studied addition and subtraction of integers, that time we studied that, sir, add 3 means we are moving right 3 steps to the right, subtract 3 means you are moving 3 steps to the left on the number line. Same approach if I give over here 3 proper concrete steps to the right, 3 concrete steps to the right, it will be something like this. Consider n is equals to 3. So 3 concrete steps to the right will be equals to, this will be my x plus 3. Can you see that when I'm moving 3 steps to the right, my this distance, whatever is the distance between this much magnitude and whatever is my this much magnitude, it's one and the same thing. Or for that matter, x plus 1, when I'm making jumps of an integers, when I'm making, sir, x addition 1, x addition 2 and x addition 3, whenever I'm making jumps, so this distance always remains same. This distance always remains same. So now x plus n, this is my x plus n, its step function. So x plus n, its step function, can I write it equal to, sir, x plus n, its step function, that is x plus 3 step function will be this part. And x step function will be this part. So you jump from the purple lines, you jump along the purple lines and then take the step function, or you jump along the blue lines and take the step function. So can you see the picturization of this property? The jump will always be of 3 units. That 3 is actually the jump of n. X plus n step function. From x, I jumped 3 steps ahead and then I came at this point, which is same as initially I went at x step x and then I jumped 3 steps ahead along the blue lines. Are you able to understand this property? That will be true only if n is an integer. Everyone?
Yes, sir.
Okay. And if you talk about the red part over here, fourth property here again I can write, if n is an integer, if n is an integer, then you can also write, sir, x, whatever that number, I did not bother, x plus n, its complete fractional part. X plus n, its complete fractional part is equals to same as fractional part of n. So what about plus n? Don't worry about plus n, it will be just fractional part of x. The red margin, the red in the same diagram that we have seen, the red parts are x plus n. Whenever you're making a jumps of the integer, whenever you're moving ahead along the purple, x plus integers, so you're moving ahead in terms of integers. So whenever you move by plus 1, the red distance is same. That red distance is the fractional part of x plus 1, where my cursor is. If you make a jump of 2 units ahead, this red distance remains the same. That is the jump. That is the fractional part of x plus 2. 3 units ahead, this red distance is the fractional part of x plus 3. This red is the fractional part of x. Fractional part of x or fractional part of x plus n, if n is an integer. Okay. They have one and the same. Okay. And that's clear. And now, fifth property.
So once can you scroll up to the third property? Okay, okay.
In step function, you have to write step x addition n. Okay.
Yes, sir.
And in fractional part, you have to write fractional part of x, nothing, addition nothing. If you want to make these two properties something similar, so you can also write it, sir, step function of x addition, so step function of n. You can write this way also, step function of x addition step function of n. So now we know that n is an integer. So can I write, sir, step function of n is equals to n? Yes or no? Because n is an integer, I can write step function of n is equals to n only. I can replace step function of n by n. Yes or no? And in the fourth property, you can write a fractional part of x addition fractional part of n. Now, sir, if n is an integer, can I strike this out? Fraction. Since n is an integer, fractional part of n will be 0. What is the fractional part of an integer? 0. Yes.
Yes, sir.
So in this, if you write it in this way, maybe you'll find it easier to remember. But if you memorize it this way, there is a chance of a silly mistake. What is the chance of that silly mistake? That silly mistake we'll see in the next property. That next property is x plus y, its step function. X addition y, its step function. Now you are very much tempted to write it in the form of step x plus step y. This step it means the greatest integer. Okay, step of x plus y equal to step x plus step y. You're very much tempted to write like previously also here we saw, but this is true only if and only if fractional part of x addition fractional part of 1 is that addition, the sum, the usual addition that we take, it's strictly less than 1. And obviously the two additions will be greater than or equal to 0 only, because both are positives. It should be strictly less than 1. Then only this property is true. So here the two properties that we saw earlier, property 3 and property 4. If you are tempted to, sir, we will memorize it this way: step x plus step n, fractional part of x plus fractional part of n, and then we will cancel out, sir, fractional part of an integer is 0, so we will cancel out this thing. Okay, that way you can do, but don't get addicted to it. Means understand it conceptually. Step x plus step n, don't be very much confident to directly write it step x plus step n. This property is dangerous property. Sometimes it's true, sometimes it's not true. Hence, it is true with a certain conditions. And what is that conditions? Fractional part of x plus fractional part of other integer less than 1. Explanation. This explanation, it's very easy. You can think of this in the form of a carry forward. While doing additions, if I tell you 17.2 and let's say 5.7. So now this is my x plus y. So this is my x plus y. Okay. If this is my x plus y. Can you see down here? So x plus y, if I tell you to do the step function 7.2.7 here 0.9 and here 22. If I do the step function, of x plus y, I can get it equal to 22. Yes, sir, this is equals to 17 step x, which is my step x. This is my 5, which is my step y. And I can get 17 plus y 22, which is step x plus step y. So what's the problem? Here there was no problem because by adding the decimals part, there was no carry forward. Now, if I give you the second example, for example, let's say 17.3 and 5.8. Now do x plus y, step x plus step y. So what is my step x? So my step x is 17. My step y is 5. This is my step x. This is my step y. So my addition should be 17 plus 5, which is 22. X plus y step function, if I tell you, step x plus step y should be 22. But what is my x plus y, sir? My x plus y, now the addition is here 8 plus 3, 11. And this one that goes carry forward, that creates a problem. 17 plus 5, 22, and 22 plus 1 is 23. And now the other step function turns out to be equal to 23. Okay. So what is our target? If you want this equality to hold true, you want that from here there should be no carry forward. There should be no carry forward means what? These additions, the fractional part of x plus fractional part of y should be less than 1. Okay. Or the algebraic proof if you want of this question. LHS is equals to step function of x plus y, which is equals to, what is my x? Can I write this my x to be equals to step x plus fractional part of x? What is my y? Y may be anything. It is, but it is always equals to step function of that y addition fractional part of that y. Yes or no? The definition of step x fractional part and those things. Now this is an integer. This is an integer m. This is an integer n. Step function. They both are step functions. Okay. So can I write this equals to, can you observe this is actually equals to fractional part of x plus fractional part of y plus two integers m and n. Means actually that's addition is also single integer only. Addition single integer, its step function. So can I take the integers out of the step, the previous property? The previous property, sir, integer is there inside, we can bring it out. I will just bring that integer outside. So that integer I will bring outside, which is my m and n. And what will remain inside is fractional part of x plus fractional part of y, its step function. Now for equality to hold true, this should for step x, step of x plus y is equals to, this is my problematic term which I want to get rid of. Fractional part of x plus fractional part of y, its step function, plus these are my nice terms, step x and step y. If I want my LHS, to be equal to only this much thing. My target is bring this to be equal to 0. This should be 0. And in order for this step function, this is step of something. Step of something should be 0. So if step of something should be 0, means what? That whatever that something is should lie between 0 and 1. Only after that the step function is 0. The previous class is sum. Step of something is equals to 1. This question. Step of something equal to 1. So that something should be greater than or equal to 1, less than 2. Step of something should be 99. Greater than or equal to 9, less than 100. Step of that something should be 0. So that something should be between 0 and 1. Is the proof clear? So the
Yes, sir.
important thing to remember.
Sir, voice is breaking, sir.
Here only is this part. If and only
Yes, your
voice is breaking. It's breaking for everyone.
Yes, sir.
Now it is over.
Okay, give me 2 minutes. I will just change the location. Just 2 minutes, okay? So just this much condition you have to remember, that step x, step y, separate. You can make it separately if the combined fractional part addition is less than 1. Okay. Now after this, x and negative x, step functions. How are they related to each other? Think for a minute. How are they related to each other? It's not that obvious. Okay. Okay, I will give you one condition. If x belongs to, if x is an integer, if x is an integer, so x and negative x, they will be simply related by a negative sign. Means step x and step of minus x, they are opposites of each other. They will carry opposite signs. I think that is obvious. But if x is not an integer, then the condition is not that simple. X does not belongs to integers. Think for a minute, how will step x and step of minus x be dependent? Take help of the number line. No, greater, I'm not talking about greater and lesser than. And Pujita, that also is not 100% correct. Step x will be greater than step of minus x. You are simply assuming x is a positive. That's why you're thinking that a step x will be greater. What about if x is negative? See, if suppose here is my x, I will take two similar points. If suppose here is my x, okay, these 2 points are similar. Similar means they are, let's say equidistant from 0. Okay, x is over here and negative x will be over here. These 2 points, the 2 purple markings are equidistant from 0. The 2 blue markings are equidistant from 0. And x is whatever to the right of this minus x. Minus x will be that much to the left. For that matter, you may also take at x is to the left and minus x is to the right if x is negative. It doesn't matter. Right now we are not concerned with the signatures. So out of x and minus x, one is to the left, one is to the right. So can you see that step x or step of minus x? Step x and step of minus x, one will be this purple value. When you take step x and step of minus x, one is this purple value and one is this blue value. But always the blue value will have magnitude greater than the purple value and in negative. So whatever is the value of x is not an integer, okay? X is not an integer. And so if suppose this is equals to 10, so this is 10, this is equals to 11. So the other part, the counter part, it will be definitely minus 11 only, the blue value. So can I say that step x and step of minus x, their combined addition will always be equal to -1. 10 and minus 11, the addition will be -1. So what about if it is not 10 and 11? If suppose you think that this is equals to 20 and 21. So this will be -20 and -21. But 20 and -21, the combined addition will be -1. So is this property clear to you?
Yes, sir.
If integers, they are just opposite signs of each other. If not an integer, their additions is -1. Okay. And what can you say about fractional part of x and fractional part of minus x?
Sir, voice is breaking, sir.
Voice is breaking again.
Yes, sir.
One minute. Okay, just okay. Is it better now? I've connected to another network. Let's hope now the problem will not come. Students have shared the OneNote screen. It should be visible.
Sir.
Okay. So now, what about fractional part of x and fractional part of -x? Fractional part of x and fractional part of -x. If x belongs to integers, I think this should be clear that if x is an integer, fractional part of x and fractional part of -x, both will be equal to 0.
Yes, sir.
X is an integer, -x is also an integer. So both the fractional part is 0. And if x does not belongs to integers, again take help of the number line, find a relation. Now x and -x, now see these two purple lines are equidistant, okay, and these two blue lines are equidistant. Now fractional part of x will be this distance. This will be fractional part of x. Can you see? Now whatever that red distance it is going ahead means, let's say x is equals to 7.2. Minus x is -7.2. So what is that 0.2 role playing? So this is that 0.2. But that is not fractional part of x, fractional part of minus x. Fractional part of minus x will be this distance. Can you see? The green distance, and the fractional part is always positive. So for if x is not an integer, fractional part of x, that is the red distance over here, fractional part of minus x, the green distance over there, the addition will be equals to positive 1. Can everybody convince themselves this point? 1 it will be, Pujita, not minus 1. Fractional
Okay,
part is
sir.
always positive. Fractional part of any number is never negative. Okay. Okay. So now this is the properties regarding step function and greatest integer function. So here the theory of the second chapter is completed. Relations and function part is completed. Now the only part remains is f, algebra of functions. Algebra of functions, algebra of real functions. Actually, it is, you just have to understand the symbol. The symbol is what? The symbol is nothing like algebra of functions. I will give you. F of x is defined. F is R to R. G of x is defined from R to R. Now it is just that a new symbol, f plus g of x. F plus g of x. Now what is this meaning? So I know the definition of f of x, it's a mapping. I know the definition of g of x. So f plus g, what is this double letter? This double letter is nothing but it is defined to be equals to f of x, g of x, and its addition. If second, here f minus g of x, this symbol itself, this symbol itself, its meaning is f of x minus g of x. Then multiplication of two real functions, fg of x is equals to f of x multiplied by g of x. Now here just keep a simple note in mind. While writing fg of x, fg of x, be careful to write it as fg only. Fg of x and f, this o g of x, these are two completely different things. They have completely different definitions. So what are the means? What is the difference? This is actually something called as composite functions, function of a function, which you will study in the next class, 12th standard. This is called as f of g of x, and this is simply multiplication of functions that we are studying right now, f multiplied by g. But they are totally different quantities, so be careful to write here. And in the paper also, now this year they won't be asking you f of g, but in the next year be careful what is written in the paper, whether it is written fg of g. Okay.
Okay, sir.
And another thing is, you can see that, sir, fg of x is equal to gf of x. Nothing difficult in it. Fg is what, sir? Fx multiplied by g of x. Gf is what? G of x multiplied by f of x. It's one and the same thing. But f of g x and g of f x, they may be same, they may not be same. There is no such guarantee. So that's a dangerous area. These two remarks keeping on. And f upon g, f by g of x. f by g of x क्या रहता है? f by g of x will be f of x upon g of x. You just have to make sure, in order for this to be defined, make sure g of x is not equal to 0. G of x is not equal to 0. That's it. Okay. So now this is algebra of functions. F of x is equals to x minus 1 under root, and g is equals to everything. G of x is also defined from R to R, where g of x is equals to five minus x under root. Now, first is find domain of f of x, g of x, f plus g of x. Second, find domain of f minus g of x. Third, find domain of x. Domain of f upon g of x. Are you getting it, students? Domain
Yes,
of f of x. What will be the domain? So for f of x to be defined, f is defined from R to R from the first set. From the first set, I will remove those problematic points which either do not form any images, or if they are forming more than one images. Sir, if you see, sir, x, it is under root of x minus 1. So can you see for the domain, the problematic points will be what, sir? For the domain, the x minus 1 should always be greater than or equal to 0. because if x minus 1 is a negative quantity, if x minus 1 is a negative one, under root of a negative quantity is not defined. It is defined in a complex numbers, but what is the set, what function he has given us, that f is going from the set of real numbers, the co-domain is real numbers. It is not a complex number system. So since we want the image to be in real numbers only, x minus 1 cannot be negative. Whatever is there, whatever complicated expression is there inside the under root, it should be greater than or equal to 0. So I want my x should be greater than or equal to 1. So domain of f of x is equals to everything greater than 1, greater than or equal to 1 up to infinity. G of x is what? G of x is 5 minus x under root. G of x is 5 minus x under root. Now same argument, G is also defined from R to R from the first set. From the first set, remove the problematic points, or for that matter, 5 minus x should be greater than or equal to 0. Because if it is less than 0, under root of negative is not defined. 5 minus x greater than or equal to 0. So 5 is greater than or equal to x. So the domain of g of x is everything less than or equal to 5. Everything less than or equal to 5 is written something like this: negative infinity to 5. And now this is the answer of the first two, first domain of f and domain of g. Okay. Now when he is telling you to find the domain of f plus g or f minus g or fg or f upon g, what is f plus g of x? F plus g of x is, sir, x minus 1 under root addition 5 minus x under root. Okay. Okay, so first of all, if I hope nobody is having such doubts, sir. If x is equals to 10, then 10 minus 1 is 9. 9 under root will be equal to 3 or minus 3. It will have two images. Don't be under that impression. Under root sign means it is, we always take the plus value. This part I have told earlier also. Under root of something is always the plus value. Now, x minus 1 under root, 5 minus x under root. So now first under root should also be defined, and the second under root should also be defined. So can I say directly that domain of f plus g is equals to domain of f, according to which the first expression will be defined, the second expression should also be defined, and you have to take the common points. Why common points? So why cannot we take the union? Because you want first function to be defined and the second function. If you take union, there may be a point where first is defined but second is not, or second is when first is not. You have to take the intersection, set intersection. Is this clear to everyone why we are taking the intersection? So
Yes, sir.
infinity intersection everything from minus infinity to 5. These two intervals intersection you have to take. So the answer is, sir, x belongs to greater than or equal to 1 to infinity and less than or equal to 5. So the answer will be greater than or equal to 1 and less than equal to 5. This will be the answer of domain of f plus g. Domain of f minus g also will be the same answer. Can I write directly now? I hope there is no explanation, there is no separate explanation for this. You can all get it. X belongs to 1 to 5. The same explanation, exactly same, just here plus sign is replaced by minus sign. Okay. Now multiplication, there is a slight difference. multiplication, there is a slight chance, means that ambiguity can occur. For multiplication, sir, fg of x is equals to, sir, what is fg? So by definition, we know that this is equals to f of x into g of x. So f of x is what, sir? F of x is x minus 1 under root, and this is 5 minus x under root. So both my under roots should be defined. Both my under roots should be defined. So sir, that yes, sir, x should belongs to 1 to 5. The first under root will be defined only if x is greater than 1, and the second under root will be defined only if x is less than 5, less than or equal to. The answer should be between 1 up to, from everything from 1 to 5. Now another student, he does like this. So see, x minus 1 under root, 5 minus x under root. We know that this is equals to under root of x minus 1, 5 minus x. Yes or no? And so this quadratic equation, we know how to draw the graph. If I want to draw the graph of this equation, negative of x square. This graph is ax square, it's negative. So negative, if I want under root of x minus 1, under root of 5 minus x. So this is equals to, sir, x minus 1, 5 minus x under root. One root is 1, another root is 5. It's an inverted u. We have seen the graph of a quadratic. And we want this expression to be positive. So this value between 1 and 5. Here you got lucky that, okay, that this is the answer. 1 minute. The point that I want to convey is something else. Okay, the point that I want to convey to you is x minus 1 under root into 5 minus x under root is equal to, in common under root x minus 1 into 5 minus x. This equality is not correct. This equality is true only with certain conditions. What are those conditions? Why it is not true always? That we will see when we will see the chapter of complex numbers. In the next class only we will start with complex numbers. Write it in the margin or in some column. Correct. In complex numbers we will see this condition, why when it is true and when it is not true. Okay. Okay, Afrin, I got your message now. I'm not able to hear you. I told my voice is clear to everyone, right?
Yes, sir.
Afrin, I think you want to ask some doubt. Afrin, your voice is not coming. Even now, I can see you're on mute, but I'm not able to hear you, Afrin. So fg is there. F upon g, one slight change will be there. F upon g. This is x minus 1 under root upon 5 minus x under root. So here now you will have to remove the points. The domain of f upon g will be, domain of f upon g will be equals to, write this thing, last point, domain of f intersection domain of g. Yeah, yes sir, this we already know. Domain of f and intersection domain of g, this we already know, minus the set of those points, minus the set of x belonging to domain of g such that g of x is equals to 0. See, initially when we were doing domain of g, initially when we were calculating, find the domain of g of x, if the image of a particular point is 0. Were we removing it from the domain? No, that was not a problem. The image can be 0. Image can be 0. That was not a problem initially. So those pre-images were included in a domain. But now we do not want those pre-images whose image is 0. Okay. So right now we do not want the pre-images where the image is 0. So here it is 1 to infinity intersection negative infinity to 5 close. Now subtract some points from the domain of G where G of x becomes 0. And when does G of x become 0? I think everybody can see this, that at a single point 5 it becomes 0. So the common interval will be, sir, everything greater than or equal from 1 to 5. 1 will be included, but now this time you will have to exclude 5. Okay. This will be the answer of domain of G of f. This was okay. Now, last question for today. This was question number 1. I think so. Square minus these two questions might look similar, but they have a minor change in them. I'll call this question number 2 and this is question number 3. Pujita, what did you write? 1 and 15. You can unmute yourself, Pujita.
Yes, sir. Yes, sir. In last class also you said no, sir. Domain and range of f of x. In that manner I did, sir.
No, here I'm writing no, but the answer that you have written is in curly braces 1 and 15. That
Yes.
is not an interval. That is not that the point that you have written. Those are actually 2 points. X equal to 1 and x equal to 15. For only these 2 values of x, the answer is defined, sir. The image is defined. That is what you have written. This symbol, sir, domain is equals to 1, 15 in curly braces. This means, sir, the domain is consisting of only 2 points. If you want to write an interval, and then you have to give something like curve, round bracket or maybe square bracket if you want to include or exclude the endpoints accordingly. But even then the answer is wrong. Even then this answer is wrong. Okay. This question number 2, just concentrate on question number 2. This question is actually nothing but I have given you a direct format of the previous question. In the previous question, I told you f separately, g separately, and then I told you find the Now I'm not telling you some numerator function separately, some denominator function separately, and then I'm asking you find the domain of numerator upon denominator function. Direct I have given you. So if at all you want to think of it as this x square minus 6x plus 8 is something as h of x. This x square minus 8x plus 15. This is something as called as p of x. And the previous, similar to previous question, I have asked you find the domain of h upon p of x. If you want to start thinking. These questions, it has just one concept, one simple concept. So denominator should be not be negative. Denominator should not be 0. If denominator is 0, then that is my problem. Numerator you can factorize it equals to, so numerator is x minus 4x minus 2. Actually factorization is not needed also here in the numerator, but okay, I will just doing it. In the denominator, the factorization is x minus 3, x minus 5. So if x minus 3, x minus 5 is the factorization of the denominator, so here I can just say that my domain is actually set of all real numbers except the point 3 and 5. Do you agree with me? Because at 3 and 5, now this subtraction that I'm doing subtraction of 2 points from the set of real numbers. I'm removing 2 points, just 2 points I have removed. So everywhere it is defined. Is this clear to everyone? This is the domain of f.
Yes, sir.
This is the domain of f of x. Domain of f of x, the complete division. Now, what about the second one, g of x? Just to confuse you, I want to tell you that this second fraction that I've given, if you factorize it, it is something like this. The numerator turns out to be equals to x minus 4 into x minus 2. And the denominator turns out to be equals to x minus 5 into x minus 2. Now, so what do I do? Domain of g of x. Should I remove from my real numbers both the points 2 and 5, or should I remove only 5? So x minus 2 to cancel hui raha hai. The x minus 2 is getting cancelled out.
Then we have to write only 5, sir.
What about others? Makran, what do you think? Makran, what do you think?
So I didn't understand the question, sorry.
The question is here. First question, did you understand how did I find the domain of f of x? Complete set of real numbers except the points 3 and 5.
No, sir.
That part is also not clear.
No.
See. Here, when we did f upon g of x, x minus 1 under root 5 minus x. See, this is an instruction for everyone. If a step you do not understand, don't wait that, sir, afterwards I will see the recording. At that point only unmute yourself and tell me. Okay. Now see, this previous question, what did we do? So we did f, the numerator should also be defined, the denominator should also be defined. Just take care that the denominator does not become 0 for f upon g of x to be defined. So numerator was defined everywhere from 1 to infinity. Denominator was defined from everywhere less than 5. And so just we have to make sure that the denominator does not become 0. So we are removing the point 5. Was this point clear to you, Makran?
Yes, sir.
Okay. So now this question and this question, what is the difference? This is under root 1 function, under root second function. This is quadratic function. This is second quadratic function, division only. So now what I am doing, okay, if you want complete step solution of the second one. So what is my f of x? My f of x is x square minus 6x plus 8 upon x square minus 8x plus 50. So what is the domain of this function? Call it as n of x upon d of x, denominator of x. Yes. So what is domain of n of x? It is real numbers only. Every polynomial function is defined for all x. Yes or yes or no? What is the domain of d of x? It is again set of real numbers. It is defined for all of the x's. Yes or no?
Yes, sir.
So what is the intersection? So for domain of f of x, what we will have to do? I will have to take R intersection R, the first domain, the second domain intersection, but I will have to remove some points. Which points? So denominator should not be negative. So I will have to remove set of x belonging to domain of d of x, the denominator function which is there, such that d of x is becoming 0. Yes or no? These are the problematic points. Previously, how we saw it. Yes or no?
Yes, sir.
So r minus 3 and 5. Now it is okay. The denominator, it becomes 0 at 3 and 5. This is
Okay,
my
sir.
x square minus 8x plus 15 equal to 0. Where does it become 0? At 3 and 5. Yes or no?
Yes, sir.
So now here, the second one, the first function is r minus the second. This denominator becomes 0. Factorization I did 3 and 5, x minus 6 minus 5. It becomes 0 at x equal to 3 or 5. Now the second one, x minus 4, x minus 2, x minus 5, x minus 2. R in intersection R will be R only. Now the problematic point, should I cancel this? Should I write just R minus 5? This is the answer. Or R minus 2 and 5. R minus, remove the points 2 also and remove the points 5 also. This is the answer. Which one? So the correct answer is, this is the wrong answer, because if you are thinking that see x minus 2 I will directly cancel out, and this function will be equal to x minus 4 upon x minus 5, then this is wrong, because this is true. This equality is true only if x is not equal to 2. Only then you can cancel out. So yes, a non-zero number upon the same non-zero number you can cancel out as 1. But what if x equal to 2? If x equal to 2, the numerator is 0, the denominator is 0, and what is 0 upon 0? Not defined. So 0, x equal to 2 is also a problematic point. X equal to 2 is also a problematic point, so that also we will have to remove. Okay, so be careful this at this stage, that here this cancellation, so here x minus 2, x minus 2, directly remove it. That cancellation is a very dangerous thing. Is the second sum also clear?
Yes, sir.
Okay.
Yes, sir.
So here functions and relations chapter is over. Try the questions from the NCERT, and in the next class we will start with complex numbers.
Okay, sir.